Hi everybody, my name's Mike. Welcome to Math 0115, the online delivery system. I've been put in charge of running all the videos for you guys. So welcome back to my class, and then welcome to Mo and Gitu's class as well. What we're going to do now is just get right into it. Obviously we have no time to spare at this point in time, so what I'd like to do is just start by introducing rational expressions to you guys. Okay, so let's start with the main definition here. That's my shorthand for definition. That's an F, not a P. The main definition just says that the general form of a rational expression is given by P of x over Q of x, where P of x and Q of x are polynomial expressions. Okay, so let's just look at a quick example here, and I apologize if things are a bit choppy here. Hopefully, as I get more and more used to the system, the quality of the video will improve. Okay, so here's an example. X squared plus 2x plus 1 divided by x squared minus 4 is a rational expression. And why is that? Well, as you can see, we've got a quadratic polynomial in the numerator and another quadratic polynomial in the denominator. Hence, this satisfies the definition above. We have a polynomial in the numerator and a polynomial in the denominator. Therefore, we have a polynomial expression. Okay, so the first thing we want to talk about here is the domain of a rational expression. And I'd just like to say this, for those of you that are in Mo and Gitu's class, I think you guys are a bit beyond this, as is my class, honestly, but I thought, make sure you watch the beginning videos here just to get used to the presentation style and stuff. I think you'll find it helpful if you kind of follow along from video 1. Okay, so the domain of a rational expression. Well, this is what it says. Since division by 0 is undefined, the domain of a rational expression is the set of all real numbers excluding the values of x, assuming we have a rational expression in the variable x. If it was a rational expression in the variable y, we would say that we're going to exclude the values of y. So excluding the values of x that give division by 0. Okay, and one thing I've kind of come to the realization of here is that, well, I'm doing this on paper, and if you're trying to take notes, then you're going to probably want to pause the video in spots to keep up. Okay, so this is going to be one of those times where I just separate this page from my notepad and start a new page. So you may want to pause the video if you're trying to take notes. Okay, so let's look at an example. Given the following rational expression, well, let's make it kind of straightforward here. Let's do x plus 1 over x minus 2. And so given this expression, let's state the domain. Okay, so it's pretty straightforward. All you have to do is look at the denominator here and figure out which value of x is going to make the denominator 0. Well, looking at this denominator, well, what's going to happen if we put 2 in for x? Maybe we can just do some work off to the side here. If I put 2 in for x for this expression, I get 2 plus 1 over 2 minus 2, which gives us 3 divided by 0, which equals undefined, does not exist. Okay, so at this point we're going to want to say this. This is my shorthand for solution, SOLN, like that. Solution. Well, what we can do here is just set the denominator equal to 0 and solve for x. What do we get? We get x minus 2 equals 0. And it's a linear equation, and with linear equations we just isolate x. So in this case we just plus 2 to the right hand side, which gives us x equals 2. Or in this case we should say x cannot equal 2, because that will make the denominator 0. Okay, now in set notation here, in set notation, we can write it like this. Okay, our domain okay, this is how we write it. It says we've got a set, and the set is all x that are real numbers such that, that's what that vertical line means, such that x is not equal to 2, like that. Okay, so that's one example. Let's do another quick example here. Let's find the domain of x over x squared minus 9. Okay, so again, we're trying to find the zeros in the denominator, And what you should see here is, well, what would happen if I set the denominator equal to 0? Well, in this case, I would have a quadratic equation. So we're going to set the denominator equal to 0, which gives us x squared minus 9 equals 0. That's a quadratic equation. And to solve this quadratic equation, if you do the factoring checklist here, which I'm sure you're all familiar with, we've got two terms, there's no GCF, so what we're going to do is factor it as a difference of squares. And for those of you that don't remember the difference of squares, it just says a squared minus b squared equals a minus b times a plus b. Okay, now we have the zero product property. We want to apply that here, and if we do that, we just set each factor equal to 0 and solve, and when you do that, here we get x equals 3 is a 0 to this equation. And here we get x equals minus 3. Now, of course, this came from the denominator. This is 0 exactly when x is equal to 3 and x is equal to minus 3. And so what we're going to do is again say, well, okay, we can't divide by 0, therefore x cannot equal 3 and x cannot equal minus 3. Okay, now in set notation, let's see if I can squeeze it in here. And say x is an element of the real numbers such that x is not equal to plus or minus 3, like so. Okay, so that's about it for this, okay, that's about it for this lesson. What you should do though is start with the u-tries. Try the questions on page 274 and 275. Okay, those are just some u-tries. I've got some worked examples to the side of them. And then for homework, make sure you complete page 276. Good. Okay, so our next topic is going to be simplifying rational expressions. That will be another video. So I'm just going to try to break this up into topics, not into 2-hour lectures. So I will see you for the next video.